Hey guys, today we are going to upgrade the low pressure fuel pump control module for the 2016 Mazda 3NA by a 2.5 turbo 1. We're also going to see how to make an acting cooling in order to run the DW300C fuel pump. You can see the older module on the right and the newest next to it. Both are looking similar. Parts number will be in the description. First, we will disassemble the old module and its PCB. Then, we will switch the new module PCB in the old module case in order to keep the cooling upgrade. The case is held by a small Phillips screw. You will only need a screwdriver. For the fans, I ordered 12 volts fans used for 3D printers off Amazon. Be sure to order them without power modulation and for the circuit protection. There is also a 0.5 amps fuse. We will say that later on. Next step is to desolder the positive and the negative. By the way, you can always use smaller gauge wires. Those are overkill for the needs. Now, we can have a clear look at the PCB. As you can see, I glued on some heatsinks on the MOSFETs and diodes. This will increase heat dissipation. Here is the negative wire. You will need to solder it there. And here is the positive one. Just solder it next to the negative. Okay, so now, once we saw the principle, we will disassemble the new module and repeat all of that. I will speed up the video a bit since we already saw how to do it. And here you can see both PCB side by side. Again, they look similar but only on the surface. This diode is the one powering the pump. It's rated at 10 to 12 amps continuous. Since the DW300 heats up to 1.4A, it can overheat, hence cooling. After some research, I saw a drop-in replacement diode rated at 20 amps. Maybe, if necessary, I will try it later on. In order to lift the PCB, just use a flat screwdriver. Now we can see the thermal glue right below the diode. From factory, the metal backplate acts as a radiator, but passive cooling ain't enough in this case. Now I will do the same thing with the old PCB. Just be careful not to break anything. Once done, we can compare both installations. Such a small amount of thermal glue. You can see the heatsinks I glued on MOSFETs and diodes. Shall have been from factory. Next, we will remove the glue remainings. That's one of the most important steps. Then clean everything with alcohol in order to prep the surface. Any strong degreaser will do the trick. We will start with the metal backplate. Then carefully scrap most of the glue excess. You can use a sharp blade and wipe it off with alcohol. The surfaces are now ready to be glued. For this, I use a thermal glue rated at 3 watts per millikelvin. If higher, better will the thermal conduction be. You'll have to put some on the back of the PCB where the old one was and also on the backplate. Don't be afraid to spread it. More is always better since you will have more surface area for heat to transfer. Afterwards, put the PCB on the backplate. Press firmly for at least 5 to 10 minutes in order to let the glue dry up a bit. Last thing is to glue the heatsinks. I use aluminum ones. If you can find some out of copper, it will be a lot better. They are approximately 1 square centimetre. They came pre-installed with double-sided tape, but I preferred to scrape it off in order to use the glue. As always, do not forget to prep the surface, clean it well before gluing. Now, you can apply glue onto the heatsinks. Found it helpful to use a small piece of cardboard to spread it. Try to make it as thin as possible, and scrape off the excess if necessary. Be sure to put the heatsink in the correct position in order to align with the airflow pushed by the fans. Then press firmly for 5 minutes, and repeat for others. Once done, it should look similar to this. This is the final step. You will have to solder back the wires onto the positive and negative as shown right here. Here, I'm using tin with 5% of flux and pre-plying it onto the connection. This will help for an easier bonding. Soldering it was quite tricky. It might be more practical with smaller gauge wires. Here is the result. I know I ain't no expert, could have done a better solder, but it will do the job. Now you can close the cover back on. Put the 2 screws in and voila, your cooled low-pressure fuel pump control module is done. I promise it will be colder than stock. Even with an upgraded fuel pump, you can then exclude thermal limitation of the circuit board and expect a better lifespan out of it. The fans will only activate when the ignition is on. Here is where the ECU sends instructions to the module. Then you have the plus 12 volts and negative from the relay/battery. And next, here are the positive and negative with power, modulation for the low pressure fuel pump. Let me know what you think of this. Now we will start the car and test it. Also, shout out to Mazda Sauce Tuning. Seems to be working fine, ain't it?